really valuable. We don't want to share it. And I'm seeing that more amongst the architectural firms who are looking desperately to create value for themselves. And they think, oh, we just do this and it's ours.
Yeah, I mean, exactly. But also more and more of these organizations, and we dive right into the discussion. But let's bridge the gap until probably 2 or 3 more people show up before we look into BIM Open Schema.
Yeah.
But I think more and more organizations also come to the understanding that building technology in the first step is somewhat fast, especially with AI, but maintaining it over time and keeping it compliant and grow it. If you like, the backpack is only getting heavier, and you need to carry it, and you need to work with it, and yeah. But I know exactly what you mean. But the last hackathon that we did, we had more of a focus on timber industry, just to bridge the gap intentionally between developers who very easily understand the potential and the benefits of open source, and rather customers like larger corporations that build exciting stuff and just dive a bit, or like are not so deep yet into the digital environment yet. And they've been investing in software, and they just say, okay, why should we open source it? Why should we give it away to our competitors and others if they're only takers?
Yeah, okay, I see what you mean. Yeah, I've got some answers for those questions, but I'll let you script this. I could talk forever about these topics, but I think you bring up some great points, Max. And I know you've got personal experience with all of this, and I think you're fighting the good fight.
Yeah. Let's just not stop it. And I've learned a lot. I mean, I've been also looking into many open source projects outside AEC.
Yeah.
And also the people behind it, and the problems are a bit similar, but also the drivers are similar. And it's just about making the drivers and the benefits more accessible. That's part of what we do with conversations like this one here. So probably let's get started. I'm recording it, exactly, so we can publish it afterwards. I will just give a quick introduction about open source construction, and then we will hand over the word to Christopher. And at opensource.construction, we are working, or like we are thinking about these topics since 3 years now, almost. And we've been dealing with many different things, exploring all different kind of ways to push the topic further. And it's my core belief that an organization like the Linux Foundation or the Apache Foundation with a strong focus on the built environment would be extremely helpful, just to kind of straighten out some publishing processes, building up trust, and just also giving people an easy access point to deal with open source solution in our space. And it's not there yet. And also open source construction, the way we are set up right now, we will not be able to do it ourselves. We would need resources, we would need buy-in from partners and everything. But what we can do is we can just keep feeding the community with content and bridging the gap between the ones that are active and the ones that just want to get a better understanding of what's going on. And that's also how we came up with the open source construction and project directory. I'm sure you've seen it on the website. It's very easy to use to submit projects, to find projects. You just link it to GitHub repos, where most of the details are in the README, so we don't have to copy paste it into some different spaces. And part of the open source.construction project directory is that we have little talks like this, very easy, very accessible, where we just introduce some of the projects that we host in the directory, introduce the people behind them, and just have open conversation about the whereabouts of open source.construction in general, but also specifically about the projects. And I'm very happy that Christopher Diggins is here. We met 2 years ago, or like 2.5 years ago, when he made all the way from Canada to Zurich with our first hackathon. And it was really cool to see also what you've been working on and your energy that you brought to the floor. It was really good to have you. And since then, we've been loosely in touch every now and then, some thoughts that we send around. And obviously we saw your ambitions with BIM Open Schema and thought it would be great to learn about a bit more about what you're doing, why you're doing it, and how others can profit and also contribute to it. I think that's also part of the conversation that we talk about upstream contributions. Just like, okay, what does it mean to use a project, but what can I do to make it better? And that being said, Christopher, I think it'd be great if you could give us just a quick introduction about yourself, about your background, so we can understand it a bit better, and then let's talk about BIM Open Schema.
Sounds good. Thanks a lot for the introduction. Very excited what you're doing with the foundation, and I think, to your point, I think it is an important thing to have a group of people who are really helping move it forward for the entire industry as a whole. And I think it gives better coordination, visibility, even if you're just helping each of the smaller projects like my own get more visibility. That is a big deal, because it avoids one of the problems that we have within companies, which is silos. You're actually helping break down silos across the open source projects, creating awareness, and people can benefit from each other. And as the technology moves and you look at other industries, you can take a benefit from that. And I'll be talking a bit about how BIM Open Schema was actually inspired by open source developments distributed by Apache, the company you mentioned, and data analytics and some of the open source work going on in relational databases. So my background, a funny way to introduce it is that I'm a failed tuba player.
Okay.
I learned to program computers when I was like about 10 years old. My dad brought home an Atari 400, and once I got bored of playing Pac-Man and Centipede, I started trying out this little basic module and typing in programs from a book. You know, at 10 years old, you're not necessarily doing anything fast, like super complicated, but I was just typing in the programs. You slowly start making changes to them. And then I started understanding how it worked. So I kind of like learned to program through these books and experimentation. Went into music and realized halfway through my music degree at McGill, started in '92, that I really wasn't a very talented tuba player. I was just doing it through hard work. When I showed some of a programming project I had done, in 3D math, one of the professors says, "Oh my God, like, are you a graduate student? What books did you use?" I was like, "Oh no, I figured out first principles." He's like, "Okay, you come work for me." So I started work almost immediately once I started my degree. And I'm actually, this is kind of a neat fact, I'm a university dropout. I got like to my 4th year and I went, "Oh, you know what? This neuroscience professor has got this great job for me. I'll take the hard route."
Okay.
Yeah. So since then, basically worked as a programmer. What's interesting is I always wanted to, have my work published in a famous programming magazine called Dr. Dobbs. It was like the pinnacle of like programming achievement in my mind. And I kept submitting articles, getting rejected. Eventually, they started accepting, and they gave me a column. Yeah, not on Dr. Dobbs, but in their sister journal, C++ Use Journal. I got a book contract. And I was doing a lot of entrepreneurial work. And then when it was time to kind of like, I was like, you know what? I'd like a full-time job at a bit larger company. And I started applying at different companies like Microsoft. They called me up and said, are you a technical writer? Are you a programmer writer? I'm like, what? What's a programmer writer? Turned out there was this intersection of technical writing and programming, and they had a role for that. And so I worked briefly at Microsoft. And then I came back to Montreal, started a family, and Autodesk, again, applied for a developer position. They hired me as a technical writer. And I was like, okay, I enjoyed the work. I was like, fascinating. All of these like massive SDKs and having to figure out how to explain it to people. And then I eventually transitioned after a few years. I transitioned over to engineer again and learned about working with legacy code bases, like 10 million lines of code written 20 years ago by somebody experimenting. You have no idea how messy these old code bases are. Oh, they're just a disaster. But it was a great experience for me. Left Autodesk, started a small business, partnered up with Vim, worked with them for a few years, when went back to it. So, I've programmed in all sorts of industries. I'm really fascinated with software engineering. I always felt like it was like something that was fun but could be made easier. Like I thought the tooling was really kind of weak, and it's really fascinating over my career to watch how much better the tools have gotten, the languages. Obviously, recent developments in AI are just blow my mind. I would have never predicted it 4 years ago. I would have just been like, no, that's impossible. And so seeing things that I really thought were impossible suddenly appearing is really changing my mind. So the last, like starting about 12 years ago, I was working on a project at Autodesk called Autodesk Live, and the goal was to bring large models from large architectural models, BIM models, from Revit into a game engine that Autodesk had acquired called Stingray. And it's kind of an interesting problem. Is like architectural models they don't go into game engines very nicely. Like BIM models, you know, they're very large, very complex, lots of objects, and game engines are usually optimized for like smaller numbers of objects, hand optimized by teams of artists. So there's this discrepancy. Like, how do you get these BIM models into game engines? And that's something I was working on for a while. Because, you know, part of my thesis is making software easier, making it easier to create good quality software. And it's like, well, it starts with the data. And so this is something I realized a few years ago, or maybe a long time ago, actually. It's always about the data. And so if you get your source input into a format that makes sense and is well designed, has no redundancy, and is well laid out, your whole software pipeline is a lot easier to work on, and it's a lot more efficient. It just takes longer to do it. In computer science, we call that kind of like solving problems by putting layers of abstraction. You kind of put a border between the input and what it is that you're consuming. By doing that, you have this flexibility to change modules in and out. And you also simplify the problem because you're no longer worried about the source program or source input. You're just working with an abstraction that's designed for processing. So that is the whole concept of how do you make data interoperability better. And that leads me to the development of BIM Open Schema, which even predates the Revit Live project. I worked in the Montreal office, not far from the FBX team. So FBX Filmbox is a very widely used interchange format for games. It's like kind of the first 3D format that a game engine will have to support, because a lot of modeling tools, Maya, 3ds Max, Blender, will export FBX models, and then you can bring them in. And one of the lead engineers on that team and I were talking about how, as the web was starting to become more and more prevalent as a target, because these are early days. This is before WebGL. Well, when WebGL just came out, but before 3GS was popular. We're like, we can't put FBX on the web. There was a blocker. You can't take, because FBX required a binary SDK to read it, and you couldn't put that binary SDK at the time in the browser. So we're like, okay, we have to rethink how we're going to move data around. And so we both came up with this idea. We called it at the time something like a scene description language. This predates obviously USD. Well, USD as a publicly known entity. It was at the same time that Pixar was working on their USD. And so a funny story from the early days is that this format, actually, we were in negotiations with the Adobe company. They had just released an API for doing 3D graphics in Flash. I don't know. It goes back to the old days of like, what the heck is Flash? But Flash is like the failed competitor of WebGL.
Yeah, exactly.
Anyway, that dwindled for obvious reasons, because WebGL was just the best choice out there. And then the project, there's only so much energy you can put into it. You've still got to, do the basic business needs of the company. And companies don't invest a lot in data formats. They don't see the end result. It's hard to tie data interop to numbers at the end. So that's kind of where these ideas of saying, look, better data representations are going to make a difference. Our goal was to create a data representation that was optimized more for the rendering component. as my friend called it, a render-friendly layout. And that's exactly where I'm at today with the geometry component of BIM Open Schema. It's got two components. One is the BIM data, which is non-geometric, and the geometric component. It's just over the last few years, I've been really thinking more and more about how do we get that massive amounts of BIM data also represented efficiently and connected to the geometric representations.
May I ask a quick question in between?
Please. Yeah.
Would you just to clarify what exactly you understand when you talk, or what you mean or have in mind when you talk about BIM data?
So it's really interesting. BIM data is two very different things. It is the output of Revit, or it is the contents of a collection of IFC files. That's it is either A or B. I mean, there's an abstraction and there's a theory behind it, but in practice, when I cross the ocean, I see two different viewpoints on what BIM data is very practically. And so for me, a lot of what I've been doing is just looking at what is the data that is locked up in Revit that is being used to generate the plans, the construction documents, and that has a lot of the useful information that could be used and is often not on a job site. So BIM data is really like you've got the output, with the 2D plans, you've got the tagging, the markup, you've got your 3D representations, and you've got enormous amounts of textual data, which it's kind of basically like I look at it and I can't help but just think of it as just a whole lot of Excel tables of data, raw, unparsed, unstructured, unvalidated garbage data. That's what's in Revit.
That's partly attributes, user-based attributes. That's partly like backend stuff to just like
a lot of parameters, stuff that's specific to families, parameters that are defined by the organization. Plus, there's also this little weird detail of all the stuff that Revit knows about and kind of stores in its API. So you've got things like, give me a second here. Revit has a specific object model within its APIs as well. I know that this thing's a wall and that there's specific characteristics of wall or certain built-in families that are not exactly exposed as parameters. So not everything is a parameter. Some things are just through the API that you can get it. So all of that together makes BIM data from a Revit point of view. In my mind, I mean, there's these experts who will explain to me that it's a lot more than that, but that's fine. In practice, it is what you can put into and extract out of Revit. The other world is it's a representation, a captured moment of time of everything going on in a project, and it is a collection of IFC files. And whatever, depending on the level of sophistication of the organization and whatever processes to decide to use, those IFC files have some meaning and they have a ton of data in them. And it really varies from organization to organization, depends on the capabilities, the tools that they've got. And there's many different ways to use IFC. There's the, I think there is a one right way to do it that nobody's figured out, but everyone can tell you when you've made a mistake.
Yeah.
Like the old days of C++ programming. Nobody could tell you how to do C++ programming, but they could tell you when you did it wrong.
Exactly. But I think that's why it's helpful to be a bit more specific about BIM data, because everyone's talking about it and then everyone's saying, okay, in the future we can do this with BIM. And that things get off the rails quickly, from my understanding.
Yeah, that's a really good point. I mean, BIM is kind of like a marketing tool, isn't it? I mean, from the early days. I mean, there's a goal of it. I mean, there's clearly a goal for BIM to actually be useful and valuable information.
Absolutely. And it's more connected, like connecting the geometry with other information that might not necessarily be maintained inside CAD programs.
That's a really good point. So, and that's kind of the holy grail. If we look at BIM data, it should not just be what is within those programs. It should be allow us to do linkages between other sources of data. Because if you think about it, everything, all of this data is valuable, including like the specification documents created early on. But sometimes, like in North America, these are created with Word templates, Microsoft Word, and it's like there's very little linkage between this, and sometimes even the connection between the actual. So, for example, you may have a plan document, a 2D plan document, but you don't know what this tag comes from. Why did the person make this mark, this note? What is that connected to? Is that connected to an RFI? Is that connected to a code compliance issue? Is that connected to a requirement? So the dream of BIM is that all of these things are connected up. You should be able to click on any aspect of the plan and say, look, I know where this comes from. And people are trying to develop tools to reverse engineer this and to figure it all out. But altogether, in my mind, this is all BIM.
Yeah, and that makes it difficult to grasp.
It's very difficult to grasp. It is a swamp of data, and it lacks connectivity between the different authoring tools and the different processes. And we see these places where the data is basically not handed over. It's not understood by one party to another at different phases during construction. You know, the most obvious one will be the operators tend to remodel facilities using a pseudo BIM, like another 3D model with data, enhanced with data, but it's completely disconnected. And so you can have well, this was the BIM model used for construction, and now here's another model that we're using for management.
Yeah.
My dream is to kind of connect these all up, and there are tools for doing this. You know, in computer science, like if you look at how data is managed outside of AAC, there's a lot more maturity.
Absolutely. So
let's ask something.
So
geometry is often the face of BIM, let's say like this, but your project emphasizes data first, or this is what you mean. How do you see this balance playing out in a practical workflow?
Well, you have to understand that a 3D geometry is only a, how do you call that? It's an approximation, okay? It's always a snapshot of a representation of it that is missing some data, right? So you can have different representations, but it's not really a ground truth, you know, like, and it evolves over time. One of the things that I've noticed is that like you might say, I'm going to have a beam here, or let's say I'm going to have a wall. This is something I've been thinking a lot about, like a wall. Well, at the very beginning, a wall is just, maybe it's just a line. But in reality, you can't build anything from a line. A line is a one-dimensional construct on a two-dimensional plane. It's like there is no dimensionality to it. But the reality is that a wall has, you know, this thickness, it has height, it has other attributes, it has a compound structure. So this grows over time. So the question is, what is the real geometry? Well, it depends what phase of the construction you're having. So what does all this mean? Well, we need to be able to think about the entity, which is the wall. The wall never changes, right? Like there's only ever one wall, but we can think about it in different ways. And as the project evolves, we are going to think about it different ways. So you're going to have different levels of representation of that wall, and we need to be able to track them and connect them all together. And you may be, because you always need to be able to talk about that wall. I say, well, you know, dude, that wall's in the wrong place. Well, how do you identify it? So there's this issue of identity, and that's an open problem. The other question of like how is geometry and the rest of the data resolved? I think they need to be kind of separated, especially on a very practical software development point of view. One of the biggest mistakes of IFC, or one of the biggest challenges with working with IFC data, is that they blend these two things together. They go, well, one format, it's got all of our BIM data. It's got all of the geometry and all of the parameters and other data and all of the relationships. All of that's together. I'm like, well, you're kind of making three trade-offs, and you're making three bad trade-offs. It's the worst format for representing parameter data. It's the worst format for representing geometry data. So is it parameters, geometry, relationships? Like you could come up with better representations of each of those three things separately. Like there's no contesting that. So it's kind of like, well, in order to put it all together in one thing, And then we're like, for some reason, everyone wanted to make it human readable, which is just bonkers. I mean, what advantage does that serve? Like, maybe lack of tools, lack of open tools forces us to kind of go, oh, well, we have to make it because the only thing we've got is a text editor. So my thinking about it is that we have to solve the identity problem so that we can link geometry regardless of how it's represented. All right. I have an opinion on how the best way to represent geometry is. And I've just started leaking that out. It's called BIM Open Geometry. And I think it's the greatest thing since sliced bread. But in the meantime, everyone else is probably going to use GLTF because it's an established standard. It's well known. And there's some people think USD is the greatest thing since sliced bread. So I can't make those decisions for people, but they need to be able to link against a good, strong, generic representation of the rest of the data, the parameters and the relationships. And BIM Open Schema started as saying, look, if it's just relationships and parameters, we know how to represent it. Here you go, boom. We're going to represent it this way. Columnar data with relationships and using Parquet as a serialization format because it's well understood and it's read automatically by multiple tools. So we're saying this is pretty good. And then Tomo developed a tool using DuckDB, runs in the browser and says, look, I can read Chris's data like that. And now we can start writing queries. And he's off to the races. And he's actually doing useful tools with it, with the data. And like, he didn't have to worry about the serialization. He didn't have to worry about the exporter. So everything's kind of taken care of on that side. So the point was, let's look at the problems separately and then figure out how to connect them without trying to solve them two at the same time. What do you think of what I'm saying, Miguel? Is it making sense? I mean, I'm open to different ways of thinking, which is
it makes sense because I'm honestly every time that I'm dealing with an IFC, I'm pretty confused. So I guess this idea of separating. So I start with confusion and then I try to organize my confusion. But maybe the problem is that everything is put together. I don't know.
Yeah. Probably the understanding helps a bit if you put it into context what else is happening in the industry. Sometimes this helps, and it's not judging any of these evolvements, but I think everyone knows about the rumors about IFC5 making everything different, but you never know when this is going to happen. And more practical, like Speckle, for example, a couple years ago, they started to say we need to be able to transfer geometry from one software to another. So they came up with their own format, build the connectors, map whatever they find to their own standard, and then remap it again. And then also that open company and Antonio, who are very much driven by results. I mean, Speckle with their data server and the exchange tools that they have, that open company with a viewer and things to build on top. I mean, that's very result driven. Without judging anything of what they did, I think they're doing great jobs. It's amazing with how little resources they manage to get good stuff going. How do you position yourself? Because it feels like you're even more fundamental, but less accessible do you know what I mean? It's not product driven.
Yeah. So yeah. I'm just thinking about the question.
Yeah, take your time.
So I am indeed trying to be results driven. I mean, that's really the challenge. When you present a new technology, you have to make it clear to people who are not experts in the domain. What is the value add? So the problem is that sometimes I've been studying data formats, 3D data formats and metadata formats for years and years and years. And my training is in that. So for me, there's certain things that are obvious and there's certain things that are like the rest of the industry has to catch up to. I'll give you a small example. Nobody was talking about columnar data formats and data representations a few years ago. Like, nobody in AEC knew about this, but this was always kind of an obvious thing. If you were from the games industry, we were kind of like, well, or anything in high performance data representations, you're like, well, you represent the data using a format known as structive arrays. We have lots of arrays, and that's very efficient. And that was the basis of the Vim format, which was incredibly fast to load. We were loading models at a fraction of the time, like monsters models of any other 3D software. And now, in order to get there, I had to create, an array-based format for quickly loading and writing. And I mean, it was accessible for a programmer because if they looked at the code, they're like, oh, that's only a few lines of code. And people who I'd worked with from the games industry said, well, that's obvious. They're like, Chris, you didn't do anything new. They're like, they told me literally, well, this is boring. Of course, this is the way you do it. Okay, fine. But then in the industry, everyone was kind of like, well, what's the big deal? Like, how do you prove people that it's got an advantage and why? So one of the obstacles was kind of like the education. All of a sudden, I said, well, somebody said, hey, look, what you're doing looks like what do you call it? It looks like Parquet files. I was like, wait, what's Parquet? And Google. I'm like, oh, well, geez, yeah, okay, fine. Converted to Parquet, and then great, everything's off to the races because Parquet was the same concept. This like array based, and then people who were kind of like aware of the ecosystem. Again, being aware of the ecosystem is kind of key here. And then they're starting to see the value of that. And like I said, Tom was able to start creating tools, and other people are starting to see the value of it. And then, of course, this corresponds a little bit too of the entity component system conversation starting to pop up, where people starting to go, hey, yeah, maybe we arrange our data a bit differently. Even game engines over the last 15 years started going, well, our game object hierarchy of trees of objects is not actually the best way. Object-oriented modeling is not the most efficient way to model your data. But I'm losing everybody here when I talk about this stuff. Nobody in the industry really cares. They really want, like you said, they want results driven. So I think the goal for me is to find partners who are solving problems that industry practitioners are experiencing. And it doesn't mean just non-technical people. There are technical people trying to solve technical problems, but they don't have time to go up and invent a data format. They're just like, well, I need to know A, B, and C. I need to put them together in an efficient way. So if I can solve those problems for people. Now, I've jumped around the question of saying, how does this relate to what we're seeing from that open company and the other one, which was IFC5. So
IFC5,
yeah, I'm gonna go at IFC5 pretty damn hard right now. The challenge with it is that it is not effectively spec'd. The design rationale of what we are doing and why we are doing it is not being documented. There is no transparency. There is the documentation was go look at this course and do this course. Show up at our summit and cheer broadly about it. It's become a marketing thing run by a couple of people who are not really exposing their decisions and really inviting actual feedback. Because I cannot provide, I would love to provide feedback on IFC5 if they were saying, here's what we're considering, here are the things that, like, here are the different options, the pros and cons, and what do you think? I think the problem again is lack of maybe experts in data modeling. And so they're just not used to people actually asking them hard questions.
But that's crazy, yeah? If you consider the impact of the IFC file format for the industry, if it's true. But I know that it's a rather small circle of people doing it.
Yeah, well, there's a small circle of people doing the hard work, and they are amazing. But the problem is that you've got all of these other people around it. You've got so many darn summits and coordinations and people, and it's kind of gotten a life of its own.
That's why I think it's interesting to see Speckle, that just circumnavigating it. Even if you say if it's good or not good, but it's like just a very pragmatic way to say, okay, we just keep away from it.
So Speckle has that kind of like you said, a very quick to get going at the beginning. All right, boom, we have this idea, centralized common data object model for our data, and we'll correct these connectors. And they did that, and they created a whole bunch of beta connectors, which were great and very powerful. But the question really is like, how do I move the Speckle data representation into other tools and connect connectors to it? I created a viewer for it, but now since then they have two complete iterations of the SDK. I don't even know anymore how to connect to it. And the business model is kind of evolving. So it's open in that they're transparent. They're saying, hey, this is what we're doing. We've put all our stuff open source, but practically speaking, there's not enough documentation. And it's if they control the entire ecosystem, it's like, well, it goes to a Speckle server, and then the Speckle object model serves it via API. You're just talking to APIs. You have no idea how to create a brand new tool or to use the Speckle object model separately. And then there's some other questions you start to ask yourself. Does it, how does it work at scale? Can I bring it in between different tools? So I'm interested in data interop at the data interop level where you only talk about data. I don't care about APIs. APIs is a secondary concept. Those are things you build on top of it. But in order to answer your question, how am I going to become results driven? Show it being used, create partnerships with technical companies who have practical problems, like saying, hey, we need to, let's say, transmit massive amounts of data, like infrastructure scale data from, a server to a client. And you're like, well, you're going to need to make it smaller, and that's going to have a practical impact. Now, I've worked with these problems at scale in the past. So,
yeah. Normalization is also part of it, right?
Normalization, yeah. Normalization's key. Now that's the key to performance. The problem with normalization is it makes your data harder to work with, in one sense, because like I had this conversation with a very, very intelligent person, and he was like, well, why don't you just make the data tables wider and put more data in them? I was like, well, you can do that, and that's actually a post-processing step. My goal here is to normalize the data so that it is very simple from a programmatic standpoint, and then your specific use cases, you denormalize the data, you create the wide tables with all of the data you want. What I'm using is a format called EAV, element or entity attribute value, and it's very, very long tables, very narrow, and lots of indexes and stuff, but it's incredibly efficient. So it's an extra programming effort to go from the normalized format to the denormalized format. But most people don't really study this, and it's fine. They don't have to be data experts. My interest is trying to use my skills and my interests to help benefit other people. So I think one of the takeaways here is that we need more partnerships between people, and people need to start going, hey, can we use this tech? Asking questions about their tech stacks, continuously questioning. What I see a lot of is championing what we have. Hey, we're doing this, is the best thing in the world. I think you should stop what you're doing and do what I'm doing. And I had that conversation a while ago, and I got kind of upset. I was like, you didn't stop to look at what I was doing. You just told me what you were doing and why it was better. And I was like, I did study what you did, and I do know, and I wanted to be nice, but I've like, it's got these issues.
So what's your ICP, like your ideal, or like IPP, ideal partner profile?
I think it's people who have problems that the technology could help them solve. And so for me personally, it actually is people developing software and tools, where there's commercial software, open source software, tools, anybody who's got a problem, and also to people who are dissatisfied with the status quo. One of the things,
what problem? Like have problem doing what? Just be transferring data, making data accessible from, like, freeing data from the Revit context and using it somewhere else. And
perhaps querying it, like saying, well, I need to run queries. I need to do validation at scale. I need to do regular, frequent updates of data. Let me see. Who else would I love to work with? People who need some aspect of the data and need it efficiently, and need to do it at scale. So maybe they're trying to create schedules, or they're trying to associate data, or they're trying to do geometric transformations. They're like, well, you know what? The geometry, I only need complex geometry here, but I don't need complex geometry there. One of the things I work a lot with is like I said, the different types of geometric representations. There are a lot of architectural firms building in-house tools, and a lot of engineering firms build those tools that are based on Revit. And it's just, those tools could really benefit from a tech stack that's a little bit more robust, and not like homegrown everything. So for example, I see a lot of people writing their own Revit exporter. Stop writing a Revit exporter. Stop that. That is a solved problem by people who are experts in the field. Myself, and let's work on now doing interesting things with that data, because a lot of people put their energy into the extraction of the data or designing their own data representations. Honestly, I would love to talk, in depth with, like, I don't want to throw stones at anybody, but I would like to talk in depth with some technical companies and saying, look, here are some ways that maybe you could consider using it. I'll tell you something, software engineers and anybody who's doing like software engineering has this problem of like, well, I didn't invent it here, so I don't want to use it or learn about it. So if anybody's got anything similar to this tech, those are the people I want to talk to and say, hey, can we replace my thing with your thing, or can you use my thing with your thing? Like anybody doing something similar with data interop, whether it's geometry or the rest of the BIM data. The next stage, I do need the IFC experts, because I told you, like, the BIM data, the representation and the way it's structured, the way it's done in Revit versus the way it's done in IFC are so different that I almost consider them two different beasts. So I've been studying it, and I've tried really hard to make sure that what I can do what I've done with BIM Open Schema can be mapped from IFC, but I need to put that into practice, and I need IFC experts. IFC is not something you can kind of go into lightly. I've studied it a lot, but the experts are there, and they know a lot more than I do. But luckily, I get to talk to a few of them. So I'll be calling up Tion soon and going, all right, dude, school me, please. And he's willing to do that, which is great.
But why is IFC so important for you? Wouldn't it be more interesting to just use, just focus on data extraction from other large CAD tools?
Well, when you look at a large number of the projects within Europe, for example, it's mandated delivery of IFC, sometimes in conjunction with the original source CAD. There's a ton of projects that have IFC, and IFC management is an open problem today.
But IFC is just like, what I think is really difficult to work with IFC is obviously the export. Like, you have data in your files, and then you export it, and then it's getting mapped to different places, and it's very intransparent, and then you find stuff here, and base quantities never works and stuff. So if I could choose and say, okay, we use IFC to kind of document whatever we did, but the work actually happens somewhere else in a way. Like, I'm consulting clients now in terms of data infrastructure, and we talk about all different kinds of data, like finance data, like scheduling data, just the warranty data, contractual data, all these kind of different things. And obviously at some point you also have building elements data. And just to be able to query content, like if for them it'd be easier if just the people could drop them a Revit file, and they could extract, probably in an open environment that they can use together, data from that file and visualize it. Doesn't even need to be necessarily linked to the geometry. It'd be nice, but and then just interact on that data, probably using LLMs to do stuff with it. Then you don't need IFC at all to do so.
No,
this could be an interesting positioning. Not to swim in the same lake like everyone else, but target a niche. Target people that really talk about data and just don't want to go the IFC route.
Yeah, that's interesting. That's really interesting. No, I mean, I'm open to that. I just I think for me, it's just like, if I'm saying that I've got a data representation that could be the universal BIM format, I think that showing the mapping to showing the mapping from IFC to it could be a real strong contender. Oh, there's a comment in the it came by, I think, on this topic. Where is it?
Yeah.
This is an OLAP versus OLTP versus.
Yeah.
Yeah. I mean, I don't really have a strong, let's say I don't have a strong pony in this race. What I need is partners. Like, I need to make this a practical problem that I'm solving, or at least I am connected in a practical problem. Otherwise, nobody's going to use my tech.
Exactly. But for example, how do you envision, I don't know, an impactful project using BIM Open Schema?
So,
what would be?
That's a good question. So, I'm developing a tool. It's a 3D viewing tool for the desktop, and it's programmable programmatic. Like I can make queries and generate, like I can make queries, I can generate geometry, and I can manipulate geometry using scripts and eventually maybe a node editor, but I don't care about node editors for now. So the question here, yeah?
When you talk about the geometry, are we talking, what kind of geometry? Are we talking about like boundary representation objects or like meshes mostly, or what?
It's all meshes.
All
So
meshes. Okay.
yeah, it's kind of like Navisworks or a game engine, right? It's everything comes in as meshes, but it's at massive building scale. And you're like, okay, I need to make queries of my like electrical system, and I need to see my electrical system like that, or I need to do coloring of objects based on some characteristic, and I want to do that instantly. And I've written a quick script, and I need to do that within my game engine, my 3D viewing tool. So there are two problems that I have to tackle. One is, how do I represent the geometry that is instance and it is absolutely massive in a way that does not break the program? So like, how do you handle instance geometry that is bigger than can be handled by traditional tools? And the second problem is, how do I represent the BIM data associated with that geometry so that I can make the query that drive what I see in my viewport? And I need to be able to query that data instantly. Virtually instantly. We want to be able to have a slider that I can just go, I move the slider and the floor that I'm looking at or the category of object turns on and off instantly. But for a 40-story building with fully coordinated, that's the goal. Like, why can we not do that? Navisworks can almost do that. It's just Navisworks is not scriptable. And this is within the realm of technology that exists today. So to solve this problem, it is all about how you represent your data. How do you give the geometry to the renderer? And how do you give your BIM data, the rest of the BIM data, to a query engine? So BIM Open Schema provides me with a representation of the data that can be queried very, very, very fast. And then I can use that within my tools. So that is one of the practical problems that I am attempting to solve, which is a way to represent it. Because you have to understand, all the 3D tools that are not BIM enabled cannot do this. They simply cannot. Like, they just think that metadata is like 5 fields and you only have maybe 100,000 objects. But the reality is that you have over 1 million objects, and BIM data can just be, you can have hundreds of fields that need to be queried. And to do that in real time is really, really hard. So I designed the format to help me with that problem. The second problem I'm attempting to solve, which is saying, oh my God, like somebody says, well, I've got 200, 500 IFC files representing a complex build project. I'm like, well, that's kind of bonkers. How do I query across all of these IFC files really quickly? You normalize the data, you put it in BIM Open Schema. Now I can query it quickly. Mm-hmm. It's just about that. This is how a lot of commercial tools work. In order, the tools that you see that work really quickly, let's say Libre or whatnot, what they're doing behind the scenes is they are converting the BIM data and the geometry data into efficient representations that they can give to the renderer and that they can give to their query engine in order to do queries rapidly. I'm just saying, look, this is actually something we can just do out in the open. We can all collaborate on it. We can all reap the benefits of tech that's like 10x, 100x better than what we thought previously. Does that answer your question? Those are two use cases. I'm open for people to come to me and tell me what they think their use cases are and where they're curious. There needs to be some exploration too. I mean, clearly some people are going to come up with ideas as they play with it.
Yeah, actually, that's the next question. So let's talk a little bit of collaboration, maybe. So
yeah,
what exactly? You said you need to collaborate with people. You need to work with people. So what is, I don't know, what are your lessons already when you have been collaborating with people, and what kind of people would you welcome? So
one of the problems for me, one of the lessons I've learned is that there's a lot of interesting problems out there, and as one of my old boss used to say, I can solve one of them, but I can't solve them all. I can solve any one of them, but I can't solve them all. It's just like, it's too much time. So I need to focus more. One lesson, focus. The other is that I am one person and I am a self-funded business. So I need to generate revenue. So a little bit wherever I can create a partnership that is funded even to a small amount, that gets my attention. So that's one of the things where I'm putting the energy, because as much fun as it is to do all of these open source projects, which I've been doing for a couple of years now, I need to figure out how I can build something to profitability. I'm not, yeah. So that's kind of where I'm trying to focus. If I have somebody who says, look, we've got a client, they've got a specific problem, and they're willing to pay for it, and we can do a little bit of a shared project where we use your tech to do it. That's perfect. Or, I did a project for Speckle once, which was they said, look, we want to improve our IFC pipeline. It's all got to be open source. We'll pay you. I did open source development. They paid me. It was great. And then they used somebody else's library in the end. But we'll come back to that. We'll help them in the future. It's complex because there's always trade-offs, right? Whether you want and complexity.
We are almost coming to an end, but I think it's been very insightful, and I think that makes it much easier also for people to understand the potential of BIM Open Schema. I think if you just bring some of these examples, probably also in a README, what like querying large chunks or like many IFC files at once and these kind of things. Just even if they seem not very helpful in the beginning, but that just gives people a better understanding for what it can do and what it does, and probably
I think you just hit on the nail on the head, did you? Because one of the questions we were considering asking me, which was, how do we help people be more successful? And it's advice like that, which is showing the application of tech, not just tech itself, but showing the application of tech to a problem. And that's actually one of the hardest things for me. It's really saying, well, okay, that's actually an interesting, rather than a constructed problem or a fake problem, which is also a trick you could fall into. Somebody goes, oh, well, that technology solves this problem, which I don't have.
Yeah, exactly.
Figuring out a good use case is a very challenging thing for somebody like myself.
It's a bit the solution seeks problem challenge that many people have to some extent.
Yeah, and I mean it's tricky when your job is like, I'm like the person who makes really good nail guns, but I don't use it. I just make the nail guns. I'm really good at making nail guns is a very different task than using a nail gun or building a house. And so again, collaboration could be very helpful here, where somebody says, we think we've got a construction problem where your tools could be useful. Let's collaborate on it. And like I'm saying, like, even though I'm moaning a bit about the lack of funding, it's not just about that. I mean, if I had a really good, solid use case that I could put on the website, that for me is very valuable. So nice, you make a great point.
Yeah, I mean, we have it in our minds right now, and I'll also consider that, probably come back to you, in the realm of making Revit data more accessible to an LLM, for example. Parsing data from different Revit files into a database and providing this context. I think that's something that I'm dealing with right now. And so we could probably have just a quick follow-up at some point and discuss how we could use BIM Open Schema to do so.
Yeah, we'd love to, because one of the challenges, I'm just going to mention this, is that you mentioned normalization of data, which I said makes the data more complex in terms of the queries. SQL queries become quite complex because you have to denormalize it within the query. So this is where LLMs can actually be really useful, because they're excellent at generating SQL. So you could actually use natural language prompts to generate queries to query the structured data and to start getting insights and to help as a tool that people can use. And even to start doing analysis where you can actually automating an LLM is, I think, the future. Like, people are like, just right now, there's a lot of like, oh, I type my thing into it, I get a prompt, and it does the thing. But
I mean, there's the whole concept of these MCP servers right now, providing them tools to work with different things. And I'm not sure whether you've looked into this, but there could be obviously a huge lever if you find ways to kind of say, okay, here's a Revit file, here's IFC files, how do you want to talk to it? And then obviously you could use IFC OpenShell, but then you're limited again to IFC. And you need to parse it, and you need to do some probably heavy operations before you get in terms of performance, it might not be the best to do these all in Python libraries and everything.
Well, yeah, that's one of the motivators here, and that's one of the reasons I talked about trying to get. The dream is to get the entire IFC into a geometric representation and a database representation that we can we can be free from IFC Open Shell, which is an amazing project, but it represents so much complexity to get that geometry out of IFC. It's massive, and so you're kind of limited by that tool. So we want to break away that we don't have a limitation where we're dependent on a tool. That's
how
the
far
goal.
away are you, how far away are you from parsing IFC files?
Oh yeah, I got a great parser. The challenge is making good quality geometry. So I can get it to a point where I can make some of the geometry, making sure it's very robust. The challenge there, it's a few weeks of work, and that is really intense work. And it's kind of like a, why? Like
why?
I do it.
Yeah.
Well, my dream here is I've applied for grants, so maybe somebody will come through with a grant for that.
Yeah, or this one would be great, or you would have just use cases that work with Revit files, and then people say, hey, we need this with another format as well. Just like this, use what you have, go deep, really find applications for it, real world applications, and then say, okay, only Revit files is not enough. We need different formats, and then you scale it. Otherwise, it's,
Yeah.
The question is like investing all the work into just something else that's like the same that you do, but in a different color. Obviously you can try it out. I would try
great
it.
advice. I agree 100%. I've done that enough that I've kind of learned it's like, okay, stop. Like you've done it once. Now just focus on what you've achieved, showing how it's useful. And like you say, other people will drive the requirements if it really has value. Eventually you'll get there.
And just come up with these examples. Just say, okay, you have 500 IFC files and you want to query about them. How do you do it? You're just coming up. You don't need to build it yet. Just coming up and talking and start these discussions with people like, okay, that are some real world examples. How would you do it? And then people will probably show up and tell you what they really need, and then you can dive deeper in and say, okay, we can build it. It's just a matter of some bugs and time to get it done. But I think it's very exciting. It's been very, very refreshing to hear your perspective again from the other side of the ocean to Europe, and I'm glad you're still on it. I mean, it's a bit of a long time game, but the more you do, the more you get exposure, the more likely it is that you'll find people that jump on it. And I will certainly come back to you for a discussion about just an introduction of what I do with my clients, and then probably you'll find some alignments.
I really appreciate that.
Very interesting.
And thanks for organizing this, folks. It was really like you and everyone is really, it means a lot to me. This is one of the hardest things, is getting the exposure and then trying to go to that next level with the things I've developed. So thank you.
Yeah, even though the audience has not been super big, but it's the same for us. We don't have the resources to advertise it weeks in advance and do everything around it. But I think for everyone who participated, it's been very insightful. Some folks might look into the recordings, and we will do it in the near future. So very happy if you join again for other topics.
Oh, I will. I'll be there, and I'll keep tooting the horn.
And let's just keep the discussion up and going. And I think it's very interesting to have it really tied to projects and people. So that's the best. Abhishek likes it also. Thanks a lot, guys, for showing up. Thanks, Christoph, for taking the time.
That's my pleasure.
And
all right,
let's stay in touch. And also don't hesitate. If you have tools, people that you work with and you think are inspiring, just hit us up and we'll put them on the agenda and do similar calls like this one. It's very easy to do so. So it's also, it's the community only lives if we nurture it all together. It stops. We try to provide the platform to do it. Great.
And wonderful. Thanks again.
Guys, have a good one and see you soon.
All right then. Take care. Thanks.
Bye-bye.
Bye-bye.